Hi, welcome to physics. I just wanted to have our first video be kind of our introduction video. It'll give you kind of a feel for how class is going to be functioning in this kind of different environment. I like to kind of do this as kind of a preview because I don't think a lot of you have ever had to work on trying to take some notes in this kind of a format. So I thought we'd work through kind of how to do note taking and structure and how functioning in this environment of a flipped classroom is going to work. Um, Again, one of the things I always look at is I always think there's new ways that we can kind of do things, and we want to be able to give different venues for everybody on how they would best learn. So I did want to start here on our introduction page and show you a couple of the things that you need to know as we go forward throughout this class. Now, really, we're here on the out of class side of the data, or on the sheet. And you can see that there's a number of things like the video that you're currently watching, and hopefully you clicked that, or you had to click that to get to this point. And then there's the readings down here at the bottom. And I want to kind of focus a little bit about the readings. Um, You'll want to make sure that you're going to be in one of two kind of areas. Either you're probably one of those people that really like to get a book, and we've probably already talked about this, and so you can pick up one of these textbooks and then kind of keep it wherever you're going to do your video watching. And so you have that with you. So if you're one of those ones that you're going to watch videos and sometimes you need to watch them here at school, you may need to carry the book around. If you always plan on doing your video watching and note taking at home, you may want to be able to just keep this book there at that area where you like to work. The other thing is that if you don't want to do the book, you can always use the linked in readings that I have here. And so you can see that for this first one, I actually have a link in here to a Wikipedia page, and it's just the general information about physics. And so kind of, I would use these as kind of a reading source to kind of bounce between as we go through content on the videos. And so you may want to take some time to pause. My goal always is that the videos themselves will never exceed kind of 15 minutes in an evening, but really when you start to look about how do I take notes and how do I incorporate the reading in that, you're probably going to be spending about a half hour of time at minimum going through some of this information so you're prepared for the next discussion, or I should say the next activity that you'll be doing in class. All right. And the other thing that I want to point out is that there's some very good web resources. Now, usually my web resources are directed to whatever the topic is that we're talking about. Because this is an introduction to physics, I have just some general links here that you can always go off of. The one that we've already used here in class would be our online problem set. We'll use some PhET simulators throughout the time. This is just the general page for that. The one that I probably use the most is this one called the Physics Classroom. It's almost like a textbook online. And if you go into here, you can go right to the class tutorials, and that'll take you into kind of like your chapters that we would be going through. I didn't select a reading from the physics classroom for this first one, and I chose Wikipedia because I was just looking for general information about physics in itself. All right, I think we're at that point. Oh, and if you're on your book, you should actually be open up your book to page 1 through 6, so you can kind of read as you're listening or watching as well. So go ahead and get yourself started, page 6, or page 1, excuse me, and or get a tab open for the Wikipedia, and we're going to begin our video. And I just want to bring this up. All right. And you'll have to bear with me. I've got a new writing utensil that I'm going to be working on the screen with, and I'm not quite sure how well my handwriting is going to be. But I wanted to just say again, welcome to physics. I know that one of the things I did before you even came in is I had a chance to kind of go through you as students. You've already completed a survey for me, so I'll be reading that survey over to see what were some of the reasons why you decided to take physics. But I know that we come in with a variety of different levels of math abilities and even science background, and so we're going to kind of try to make sure that I can reinforce whatever it is that you need along the way, and that's why I have so many different resources available to you. Um, First of all, we want to talk a little bit about what is physics. And you may remember from ninth grade science that physics was that topic area where you got to launch some rockets. Maybe you were studying the motion of a car going down a ramp. And, maybe you got a chance to use some photo gates. But you had a chance to look at matter and how the matter is moving. When we really look at this, we look at this in terms of its the forces that are attached to that matter, and really when we start to talk about modern physics and concepts of where we're at currently, really all matter is a form of energy, and then there's the interactions between these energies, and that's what we refer to as these forces. So we have energy, and we have force, and we have matter, and that's kind of what we like to look at when we do this. Physics really started out as like the title says, a natural philosophy. It was one of those things that we walked around our planet, and we looked at all the different things and we said there's got to be explanations for some of it. And so that's what they're currently trying to do is try to explain what why everything happens the way it happens. It's kind of our goal here in science is to try to look at those. Um, as we have progressed, we're getting closer and closer to try to unlock, things like how did the universe get created, okay, and that, and so we're kind of at that point now to where we're smashing atoms together to look at interactions between those our subatomic particles like quarks, and now we've even discovered that there's new particles out there, and we've um, used our scientific method to kind of determine what could be our next step along this way. And just recently, this last year, we discovered the Higgs boson. So that was kind of an interesting thing in our science community and our physics world. Of course, as we have progressed in our discovery of the world around us, we've implemented new technologies, and the new technologies have allowed us to um, discover more. So if you consider the fact that like when we first were looking at atoms and trying to figure out what their nucleus looked like, we had Ernest Rutherford back in the early 1900s do an experiment where he shot alpha particles at gold foil, and then he got some bouncing, some scattering, and that kind of told him about what the nucleus would look like for an atom. So we were able to determine that. And that was pretty basic at that point. When we look at where we're at now, now we have a particle accelerator. So if you go, to CERN or Fermilab, you're able to actually see different uses of how we can accelerate particles and then interact those particles with each other. We actually have a project that's working through Chicago and Fermilab where they're sending neutrinos up, and we're trying to capture those neutrinos and see what their behavior is like. And again, it's all about this quest for um, how did our universe come to be, and is there such a thing as dark matter, and what is, why, how did the universe um, start? Okay, so those are things that we're looking at. All right. As we go in here, I did mention the things about the scientific method, and you can see that they'll talk about the scientific method in both the book, and if you scroll down through the Wikipedia site, you'll see that as well. But when we look at scientific method, it's kind of that thing, it's a process or a way of thinking, and we've been talking about this probably in your science classes for many years now. But it's fairly logical. We usually have something that we observe, we see, and then we collect some data on that. We get some information about that observation, that problem, that situation, and then we try to think about what's going on with it. Okay, so we start to do that analysis process, and that usually that analysis process will lead us into kind of a this is what we think is occurring, and this is why we think it's occurring. So we build that hypothesis. And that hypothesis is really something that's going to be the basis for how we create a test. Okay, we're going to see if things are working right, if it works the way that we want it to. So we develop an experiment based upon what our hypothesis says. So a hypothesis has to be something that's testable. It's not just a random thought about it. Now, if we go through that, we can then say we test our hypothesis, we see how did it come out, so we circle back to our analysis here. Let me just make sure that my pen tool is turned on. All right. And so if we look at this again, we come to this analysis portion, and we circle into our testing portion, and then we come from our hypothesis back to our analysis, and this becomes kind of a loop in our thinking. Eventually what happens is we get some pretty good ideas of what's going on, and that's where we can then say our hypothesis now is making it turn into something that's more one of these scientific theories. And really when we start to look at this is kind of our process that has happened with things like the atom. Okay. So the atom has undergone many different kind of changes in what the atom looks like. And you may remember that the atom from our ninth grade perspective is that it's got some subatomic particles. It's got protons, it's got neutrons, and it's got electrons. Well, we've actually gotten to the point now to where we know that there's even subatomic particles from the protons and the neutrons. Those are our quarks. And we can even have things other than electrons that are maybe heavier. So that's a muon. And then we have our interaction kind of forces, but those forces almost act like particles, and those are our bosons. And so we have all of these different things that lead us into changing our theory as we progress with our changes in our technology. The last thing we kind of want to talk about in this video, and I see that we've only got about 3 minutes left, is I like to look at data. And the reason why we wanted to discuss data analysis or interpreting information is because those are some of the first activities that we do here in physics. So when we collect information, we usually like to do something like a scatter plot of this. And a scatter plot really is doing something where it takes a variable, in this case it's the square feet, versus the home price, and we can then make kind of a change between those two. Hold on. Okay, so I'm back here. I had just a brief little interruption here, and I wanted to bring back where we're talking about the two variables. So in other words, we usually have one variable that we call an independent variable. And independent variables like to be on our x-axis. And our dependent variable then, that's our variable that we're probably going to be looking at to see how it changes, would be our y-axis. And so you can see that we're going to be looking at our home price per square foot, and we get kind of some data that we collected. Now generally when we look at data, we like to look to see if it trends, okay, and so we can see if it has some kind of a correlation between them. And ideally in science, we really like to look at it in terms of is it linear or is it nonlinear, okay? Linear relationships are wonderful. We can see that the data goes up, okay? So as one variable increases, the other variable responds by increases, okay? And that's a linear fit. So we can do a linear model, and anytime we do linear models, we get to the point to where we can build in, a y equals mx plus b relationship, and that's how we then build our trend line. In an indirect relationship is one where the one variable goes up and the other variable goes down. And those kind of relationships, we generally don't see them do linears. We usually see them do something like that. Okay, so those are our indirect relationships. Again, when we start building this stuff, you know, we look at it from a math perspective, and this is probably going to be our biggest thing, is to be able to figure out how to find slope. Okay, and so slope is going to be our biggest, most important thing when we start talking about rates and changes here in physics. We should have an activity for in class tomorrow. I believe that we'll be looking at either some dots or we'll be looking at chewing gum. And we'll see you in the next video. Happy physics.